Multiplying. Okay, I gave you this one because one of the examples today, what's another way you could have written these two problems?
4x minus 3 squared.
Okay, this is the same thing as saying 4x minus 3 quantity squared. So today you're going to see some of the problems like this, and all you have to do this problem is write it out twice and FOIL it or use the box method, whatever method you want to use, okay? So let's grab notes for P3, last part of it.
Did we turn in
Our what?
We're turning this in.
No, we're adding on to it.
Okay.
Holly's part 2. Okay. Let's get going and get through these two examples. Like I said, the first one is basically our bell ringer, so that's a really quick example. The second one might take us a little bit longer because we got to refresh the Pascal's triangle. Yay.
How many
So,
classes do we have today?
3. We're adding on 3 problems. Some people still need to finish some from yesterday, and then we'll go over all of it at the end of class. So here we go. 6x minus 5. Quantity squared. You guys work this one on your own. What does the quantity squared mean again?
Write it out twice.
Write it out twice. So you guys work this one on your own. One more time. Oops, 6x minus 5. And we'll compare answers. Then we'll move on to the fun stuff. Okay, is this what you guys got also? Yes, 36x squared minus 60x plus 25. So this is nothing new. It's just written in a different form. So it'll be written like this. Just write it out twice, FOIL or use the box. Yes?
Why isn't the negative 60? Why isn't it squared?
Because you just added them together. You don't square when you add, just when you multiply. We didn't multiply 30 and 30. We added them. Okay, so let's recall Pascal's triangle. Let's remember if we remember the pattern. Here is the top of Pascal's triangle. 1, 1, 1. Here's the third line. 1, 2, 1.
All these are easy.
Do you remember the next line?
I have no idea what this is.
1, 3, 3, 1.
Oh, very good. Let's do the next line.
1, 4,
6, 4, 1. Okay, so when you're creating Pascal's triangle, all you're doing to create Pascal's triangle is adding together the pieces. So starting with the third line, you always have ones on the outsides, and then you add together the middle to get the numbers. So this is where we got the 2 is from these 2 ones right here. And then the ones are always on the outside. And then you get the 3 from 1 plus 2, and then 2 plus 1. And then you always have the 1s on the outsides. Then you get the 4 from the 1 plus 3, 6 from the 3 plus 3, 3 plus 1, and then the 1. So you guys write down the next row on your own. And the good news of today is we're not using the Pascal's triangle very far. I think your homework only goes here. The third. So okay, so the last line here would be 1, 5, 10, 10, 5, 1. Right? Okay, so here's how you use this. This is our squared level. So this is raised to the second power. This one is raised to the third power. This one would be raised to the 4th power, and this one's raised to the 5th power, and then it goes on and on. This number here is always what I tell people to look at what power you're using, okay? Now, obviously, second power you're just going to write it out twice and multiply it, like you just did on that last example. You're not going to use Pascal's triangle because it's as quick to write it out twice. Once you get to the third power, you're going to, instead of writing it out 3 times and foiling it and then foiling it again, you can just use Pascal's triangle. And let me show you how you use Pascal's triangle. So the problem we have is 3x plus 2 raised to the third power. Now, this can be done by writing it out 3 times and multiplying and then multiplying. You can do it that way if you want to. It gets a little tedious when you get to the 4th power and the 5th power and you're having to write it out a bunch. It just is going to take a long time. Pascal's triangles, this is how you use it. You look at what row you need to use, or what row. So what row is third power?
1, 3, 3, 1.
Okay, so these are your coefficients. So I'm going to spread this out. 1, 3, 3, 1. Just starting to come back to you a little bit. Okay. I'm going to tell you that I think the problems you're going to have in college algebra are easier than ones you did in Algebra 2. But here's how you do this. So I'm going to take the first term, which is 3x, and I'm going to run that to the right. And I'm going to start with 3x to the third power. Then I'm going to have 3x to the what power? Second. Remember, we would go down. And then 3x to the first power. And then 3x to the 0 power is nothing. So you just take the first term. I've done 0 math. All I've done is taken the first term, and I've written it to the third power, because that's what we start with. Then I write it to the second power, and then I write it to the first power.
And then you take the 2 and you do the same thing.
You do that
But you
the
go the other
opposite
way.
way. Yep. I can't get this. I don't know why this one won't work.
I got it.
Oh, I got it. Okay. So here's the 2. Now I'm going to start at the other end for the 2, and I'm going to go 2 to the third power, 2 to the second power, and then 2 to the first power. So again, I've done 0 math. All I've done is taken the right-hand side, started at the right-hand side, and worked my way left. So now you're going to start with math, which is just exponents and multiplying. 3 to the third power. Always do the powers first. 3 to the third power is going to give you 27x to the third power times 1, which is just 27x to the third power. Plus, let's do this power part first. 3x to the second power is going to be what? 9x squared. So now I just have 3 times 9 times 2. What's 27 times 2?
52 or
54. So I have 54x squared. If you need to use a calculator, get a calculator.
Supposed to, you start on the outside, not the inside of the one, for the 2 cubed. Wouldn't the 2 regular 2 go in the other, go 1 over?
No. You start on the very last one, just like we started at the very first one.
What do you
For the
mean?
cubed. The cubes are on the ends.
Yeah, but that one's on the inside of the one. Why is it that?
Oh, it doesn't matter which way you write it. It doesn't matter. I just always write my coefficients first. That doesn't matter. Multiplication doesn't matter.
How did you get 54?
I just multiplied this together.
9 times 2.
All of that. Okay, what is this squared? 4. So now I'm going to multiply all this together. So 3 times 3 is?
9
Times 4 is?
36.
36. So I have plus 36 and then just an x. And then plus 2 cubed times 1 is just 8. So if you need a calculator, grab a calculator. There's nothing wrong with using the calculator to multiply. But this part, now all you're doing is multiplying. I'm going to tell you to make sure to do the powers first. That's how I wrote these little numbers up here. And this is what you get when you multiply that together 3 times.
I remember this.
You remember it?
Yep.
Very good. Okay, let me give you one to try on your own.
Because how I had it, which it would have been wrong because I had the 2, the regular, like the 2 to the first power by the 3x, then it wouldn't be 27. You know what I'm saying?
Oh, no, you need to stop there. Stop there. Okay, you guys try another one. We'll do the third power again. Let's do 2x plus 4, quantity squared, or quantity cubed, I'm sorry.
Are you always only gonna have 2 numbers?
Yeah, these are for binomials. Okay, 2x plus 4 raised to the third. So I'll get you started. What are the coefficients again?
1, 3, 3, 1.
1, 3, 3, 1. Okay, you guys try this start to finish, and let's compare. I'll start my work up here just in case you need someone to follow. Times 16.
96.
Thank you.
64.
Okay, is this what you guys got?
Yep.
Here are some common mistakes if you did not get this. If you got a 6 here, you did 2 times 3. Make sure you do 2 to the third power. Some of you might have forgotten to take it to the 2, so you might have a 2 there. So make sure that the exponent goes to both things. Also, just make sure you're doing the power first before you multiply everything together. Okay? Good enough? Okay. So you have 3 problems to add on to yesterday's work. And, oh my gosh, you guys have lots of time to do these 3 problems. But you're going to do 72 to 76 in the same section. So around page 29. 72 to 76 even. There's 2 Pascal's triangle and 1 you just FOIL. And make sure the whole thing is done from yesterday through today's.